Hello, my dear children. Welcome to the mathematics class. Today, we are going to discuss conic sections. In this chapter, we have discussed the concepts of exercise 11.2 in the previous class. That is, the concepts of parabola in the exercise 11.2. I hope you have understood the concepts of parabola, and I hope you have done the first 5 questions in the exercise 11.2. Haven't you, my dear children? Right. Now come to the exercise 11.3 concepts. Today we are going to discuss exercise 11.3. Are you ready to listen to the class, my dear children? Right. In this exercise, we mainly focus on ellipse. This is the third kind of conic section. Okay, my children. So let us discuss the definition of an ellipse. What is meant by an ellipse? An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. Okay, my children, this is the definition of an ellipse. Ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is always a constant. Okay, my children, right. The two fixed points are called the foci, plural form of focus, of the ellipse. Okay, my children, the two fixed points in the plane are said to be foci, the plural form of focus. Okay, my children, to understand this definition, let us take geometrical representation, diagrammatic representation of an ellipse. So observe this figure, my dear children. 11.20. In this figure, here F1 and F2 are two fixed points in the plane. Okay, my children, these are the two fixed points. Here, these are some points in the plane. Okay, my children, these points are such that the distances from these 2 points to these two fixed points, the sum of the distances from this point to these 2 points and the sum of the distances from this point to these points and the sum of the distances of this point to these 2 points, all these sum are constant, same. That means P1 F1 plus P1 F2 is equal to P2 F1 plus P2 F2 is equal to P3 F1 plus P3 F2. Understood this point, my children? The sum of the P1 F1 denotes the distance of the point from P1 to F1. P1 F2, the distance of the points P1 and F2. So the sum of these two distance is equal to, similarly here P2 F1, P2 F2. So sum of the distances from this point P2 to these 2 points P2 F1, P2 F2 is equal to, similarly P3 F1 plus P3 F2. All these numbers are equal. Then these points form an ellipse in the plane. The set of all such points form an ellipse. Understood this point, my children? Right. Note, the constant, which is the sum of the distances of a point on the ellipse from the two fixed points is always greater than the distance between the two fixed points. Okay, my children. This number, okay, my children. This number, the constant, what we got here, the constant, is the greater than, this number is greater than the distance between these 2 points, fixed points F1 and F2. Okay, my children, just like triangle law of addition. Suppose if we are joining these 2 points, then we get P1, F1, F2. It is a triangle. Yes, number 7. So sum of the two sides equal to the greater than the third side. Yes, number 7. Understood this point? Right. In the previous slide, we had discussed the definition of an ellipse. Okay, my children. Right. Now let us discuss center, major axis, minor axis, and vertices of an ellipse. Okay, my children. What is the center of an ellipse? What is the major axis of an ellipse? What is the minor axis of an ellipse? And what are the vertices of an ellipse? Okay, my children. Right. The midpoint of the line segment joining the foci is called the center of the ellipse. The line segment through the foci of the ellipse is called major axis, and the line segment through the center and perpendicular to major axis called minor axis. The endpoints of major axis are called vertices of the ellipse. Okay, my children, understood all these 4 points. What is meant by center? Center is nothing but the midpoint of the line segment joining the foci. The major axis of an ellipse is nothing but the line segment through the foci of the ellipse. Now come to minor axis. The line segment through the center and perpendicular to the major axis is called minor axis, and the endpoints of major axis are called vertices of an ellipse. To understand these concepts, let us take a pictorial representation of an ellipse. Okay, my children. Observe this figure 11.21, my children. This is an ellipse. These are fixed points. What are these fixed points called, my children? Foci. Yes, sir, my children. So the midpoint of these two fixed points is called center of the ellipse. Okay, my children, understood this point? Center of an ellipse means. Then the line segment through the foci, this line segment, the line segment through the foci of an ellipse is called major axis. This one, AB, this line segment AB is said to be foci. Next, to come to the minor axis, this one. What is that minor axis? What is meant by minor axis? The line segment through the center and perpendicular to the major axis is called minor axis. Okay, my children. And these endpoints, the endpoints of these major axes are called vertices of the ellipse. 2 vertices are there. Okay, my children, understood all these 4 points? Right. In the previous slide, we have discussed what is meant by major axis, what is meant by minor axis. Now, let us discuss these points. Length of major axis. What is the length of major axis? Because it is a line segment. Yes, sir, my children. Similarly, length of minor axis, it is also a line segment. So we have to find length of the minor axis of an ellipse. Similarly, distance between the foci of an ellipse. Now let us discuss these points in this slide. Okay, my children, right. And length of semi-minor axis and length of semi-major axis. We discuss all these points in this slide. Okay, my children, right. We denote the length of the major axis by 2a, the length of the minor axis by 2b, and the distance between the foci by 2c. Thus, the length of the semi-major axis is A and the semi-minor axis is B. Understood these points, my children? So, please remember these points as a formula. Length of the major axis of an ellipse is 2a. Length of the minor axis of an ellipse is 2b. The distance between the foci is 2c. The length of the semi-major axis is a and the length of the semi-minor axis is b. To understand these concepts well, let us take this figure 11.122. 11.22. See this figure, my children. Observe this figure, my children. Here, this is the major axis. So the length of this major axis is taken as 2a. Length of the minor axis. This is the length of the minor axis, 2b. Above b units and downside x-axis b units. Here, right side of the y-axis is a units and the left side of the y-axis is a units. Please remember all these points well, my children. Similarly, distance between these two foci, 2c units. So 0 to f1 c units, 0 to f2 also c units. Okay, my children. Now come to semi-major axis. Semi-major axis means O to this end point, O to one end of the major axis, and this one also. This is also said to be semi-major axis. Similarly, semi-minor axis means the center of the ellipse to one end point of the minor axis. Similarly, minor axis, center of the ellipse to any end point of minor axis. Understood these points, my children? Please remember these points as a formula. Okay, my children? Right. Now we are going to discuss the relationship between semi-major axis, semi-minor axis and the distance of the focus from the center of the ellipse. Here we are deriving the relationship between semi-major axis and semi-minor axis and the distance of the focus from the center of the ellipse. Okay, my children? Right. Observe this figure, my children. 11.23. Previously we have defined the length of the major axis, that is P, or length is 2a units. Similarly, this one, this length is 2b units, length of the minor axis. Distance between the two foci is 2c units, and length of the semi-minor axis is b units. The length of the semi-major axis is a units. Okay, my children. Then what is the distance between f2 and p? A minus c. As I mentioned, because this total length is a units. 0 to f2 is c units. Understood this point, my children? Now we know here this is a c and this is b. So by using the Pythagoras theorem, we get F2 Q length. By using the Pythagoras theorem, F2Q is square root of b square plus c square. Understood this figure, my children? 11.2. 2, 3. Right. Take a point P on one end of the major axis. Here we have taken a point P at one end of the major axis. Okay, my children, see here. P is taken at one end point of the major axis. Sum of the distances of the point P to the foci is F1P plus F2P is equal to F1O plus OP plus F2. Understood this step, children? Here we are finding the sum of the distances of the point P to the foci. Then what is the sum of the distances from the point P to foci? Pf1 plus Pf2 or F1P plus F2P. As I mentioned, understood this is part, right? That is equal to here F1P. See this figure, F1P can be written as F1O plus OP. Sum of these two line segments gives F1P. Yes, children. So we have written F1P as F1O plus OP. Understood these two terms, my children? Plus we wrote this term as it is F2P. Understood this point, my children? Right. Since F1P is equal to F1O plus OP. Because of this reason, we wrote these two terms instead of F1P. Okay, my children, understood this step? Right. That is equal to C plus A plus A minus C. Okay, my children, understood this step? F1O. F1O. What is the length of F1O? CU units. Okay, my children, understood this first term plus OP. What is the distance between these 2 points O and P? Yes, A units. Understood this second term, my children, plus third term F2P. We have found F2P A minus C. Understood these last two terms, my children? Understood this step? Right. That is equal to 2A. By simplifying these four terms, what will you get here? C. Here minus C. Plus C minus C gets cancelled. Here plus C minus C gets cancelled. And A plus A gives 2A. Understood this step, my children? So F1P plus F2P is equal to 2A. Okay, my children? Right. Now take a point Q at one end of the minor axis. Okay, my children, see here we have taken a point Q at one end of the minor axis. As we have taken a point P at one end of the major axis, similarly here we have taken a point Q at one end of the minor axis. Okay, my children, understood this point? Understood this step, my children? Right. Sum of the distances from the point Q to the foci is, as we have found in the case of the point P, here also let us find sum of the distances from the point Q to the foci. Okay, my children? Right. So what is the sum of the distances from the point P, from the point Q to the foci? F1Q plus F2Q. That's the number, children. F1Q plus F2Q is equal to, we have found F1Q. This is nothing but square root of B square plus C square. Understood this first term, my children? Right. Plus F2Q. This is also square root of B square plus C square. Understood these two terms, my children? Right. That is equal to, by adding these two terms, what will you get finally? Yes, 2 root of B square plus C square. Understood this statement, children? Right. Since both P and Q lies on the ellipse, here what are the positions of the point P and Q? Yes, the points P and Q they lie on the ellipse. Yes or no, children? This is point P is at one end point of the major axis and the point Q is at one end of the minor axis. So they are lie on the ellipse. Okay, my children? Right. By the definition of the ellipse, we have 2 root of a square b square plus c square is equal to 2a. Okay, my children? We have equated these two quantities. We have equated these two quantities. So, because this is the sum of the distances of the point P from the foci. This is also sum of the distances of the point Q from the foci. Both denote the same as children. So, these two quantities are equal. We have equated these two quantities. Understood this statement, children? Right. This implies root of b square plus c square is equal to a. Understood this statement, children? Here on both sides 2 gets cancelled. Then we get root of b square plus c square is equal to a. Understood this statement, children? Right. This implies b square plus c square is equal to a square. By taking squares on both sides, squaring on both sides, we get to b square plus c square is equal to a square. Understood this statement, children? Right. This implies c is equal to root of a square minus b square. From this equation, we found the value of c in terms of a and b. So, c is equal to root of a square minus b square. What is the letter c denote here? What does this letter c denote here? Yes, the distance of the focus from the center. What is the letter A denote? Length of the major axis. What is the letter denote B? Yes, the length of the minor axis. So this is the relation between the length of the major axis, semi-major axis, the length of the semi-minor axis, and distance of the focus from the center of the ellipse. Okay, my children, please remember this relationship. Please remember this formula. Okay, my children, right. In the previous slide, we have discussed the relationship between the length of the major axis, length of the semi-major axis, length of the semi-minor axis, and the distance from the focus to the center of the ellipse. That is c square is equal to a square minus b square. Yes, sir, my children. Right. Now, there are some special cases of an ellipse arise. Let us discuss these special cases of an ellipse. In the equation c square is equal to a square minus b square obtained above, we keep a fixed and vary c from 0 to a. Suppose if we fix the value of a and we change the value of c from 0 to a, then what will happen? Let us see. The resulting ellipses will vary in shape. Then we get two cases as follows. Okay, my children, right. See case 1. When c is equal to 0, both foci merge together with the center of the ellipse and a square is equal to b square. that is A is equal to B, and so the ellipse becomes circle. Observe the figure, my children, 11.24. The circle is a special case of an ellipse which is dealt in section 11.3. Okay, my children. Observe this figure 11.24. In this figure, suppose C is equal to 0. What is meant by C here, my children? Do you remember that point? Yes, the distance of the foci from the center. If C is equal to 0, then foci merge together to the center. Yes or no, my children? This case arises. Then the two values a square and b square becomes equal. These two will become equal. So the ellipse becomes circle. Ellipse changes into the shape of a circle. This is a special case of an ellipse. Okay, my children, right. Now come to the case 2. When C is equal to A, then B is equal to 0. The ellipse reduces to the line segment F1, F2 joining two foci. Okay, my children. So this is the second case. When we take the value of C is equal to A, then B is equal to 0. Then we get this geometrical figure. That is figure 11.25. Observe this figure 11.25, my children. Here we get, in this case, when C is equal to A and B is equal to 0, then we get a line segment join the two foci. These two cases arises. These are said to be special cases of an ellipse. Okay, my children, understood these cases? Right. Now let us discuss eccentricity of an ellipse. This is the new concept. The eccentricity of an ellipse. What is meant by eccentricity of an ellipse? How to find eccentricity of an ellipse? In this slide, we are going to discuss. Okay, my children, right. The eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to the one of the foci and to one of the vertices of the ellipse. Eccentricity of the ellipse is denoted by small letter e. That is, E is equal to C by A. Then, since the focus is at a distance of C from the center, in terms of the eccentricity, the focus is at a distance of AE units from the center. Okay, my children. This is a definition of eccentricity of an ellipse. Eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. Understood this point, my children? Right. Simply to say, eccentricity of the ellipse is denoted by small letter e, that is equal to C by A. What does the letter C denote here? Yes, distance of the focus to the center. Yes or no, my children? Please remember these points, my children. What does the letter A denote here? Yes, the length of the semi-major axis. Yes or no, my children? Right. Then the focus is at a distance of C from the center. In terms of eccentricity, the focus is at a distance of AE. Yes or no, from this equation, C is equal to AE. We get C is equal to AE. Previously I told you, what does the letter C denote? The distance of the focus from the center. So in terms of eccentricity, we can define the distance of the focus from the center of the ellipse as AE. Okay, my children, understood this point? Right. Now let us discuss standard equations of an ellipse. Okay, my children, right. The equation of an ellipse is the simplest. if the center of the ellipse is at the origin and the foci are on the x-axis or y-axis. The two such possible orientations are shown in figure 11.26. Okay, my children. The ellipse is in the standard position, or the standard equation of an ellipse is simplest when the center of the ellipse is at origin and foci should be either x-axis or y-axis. Understood this point, my children? Then the ellipse is said to be in the standard position. Then the equation of the ellipse is said to be standard equation. Okay, my children? Right. Observe this figure 11.26. See here in this figure A. In the figure A, the equation of the ellipse is x square by a square plus y square by b square is equal to 1. Here center of the ellipse is origin. Center of the ellipse is at the origin and foci. The foci lies on x-axis. In this case, if the foci are on x-axis and the center is at origin, then the equation of the ellipse is x square by a square plus y square by b square is equal to 1. Conversely, if an ellipse equation of the ellipse is given x square by a square plus y square by b square is equal to 1, then we have to remember this figure. Remember this figure, my children, where A is greater than B, because A denotes length of the major axis and B denotes length of the minor axis. Yes, sir, my children. A greater than B. Otherwise, A square is greater than B square. Understood this point, my children? Similarly, come to this second figure B. X square by b square plus y square by a square is equal to 1. If you observe this ellipse, the center of the ellipse is origin, but the foci lies on the y-axis. In this case, the equation of the ellipse is x square by b square plus y square by a square is equal to 1. Previously I told you B denotes length of the minor axis and A denotes the length of the major axis. Here major axis is along the y-axis. Minor axis of this ellipse is along the x-axis. That is why x square by b square plus y square by a square is equal to 1. Equation of this ellipse is x square by b square plus y square by a square is equal to 1. Conversely, if this equation is given, okay, my children, here B, this is always less than A. Please remember this point, my children. Whereas here A, this coefficient, this number is greater than this number. But here, this number is less than this number. Understood this point, my children? These two equations are known as standard equation of the ellipse. These are the two cases. Throughout this exercise, we use these two equations only. Derivation of these equations is not needed. That is why I am not explaining the derivation of these equations. Okay, my children, please remember these equations. These two equations, standard equations of the ellipse. X square by a square plus y square by b square is equal to 1. Immediately this figure should come into your mind. If x square by b square plus y square by a square is equal to 1 is given in the question, immediately this figure should be in your mind. Understood this point, my children? Right. In the previous slide, we have discussed the standard equations of the ellipses. Two cases, two types of standard equations of the ellipses. Yes, sir, my children. Now let us discuss observations. What are the observations we found in these two equations, in these two cases? Let us discuss these points in this slide. Okay, my children? Right. Note, please remember this point, my children. The standard equations of ellipses have center at origin and the major and minor axis or coordinate axis. Yes, sir, my children. However, the study of the ellipses with the center at any other point and any line through the center as a major and minor axis passing through the center and perpendicular to the major axis or beyond the scope here. In this exercise, we focus on the equations in the standard form of an ellipse. If you take center of the ellipse at some other point in the Cartesian plane and we take major axis through the center and minor axis which is passing through the center of the ellipse and perpendicular to the major axis, it is beyond the scope of this syllabus. Okay, my children, right. From the standard equations of the ellipses, observe the figure 11.26. We have the following observations. We observe the following points. First point, ellipse is symmetric with respect to both the coordinate axes. Since if ordered pair x comma y is a point on the ellipse, then minus x comma y comma ordered pair x comma minus y and minus x comma minus y are also the points on the ellipse. If you take any point on the ellipse x comma y, then minus x comma y, x comma minus y and minus x comma minus y, all these 4 points lie on the ellipse. So we say that the ellipse is symmetric with respect to both the coordinate axes. By observing the figure 11.26, you observe this point. You can find this point. Okay, my children, understood this point? Right. Now come to the second observation. The foci always lies on the major axis. Yes, sir, my children. The major axis can be determined by finding the intercepts on the axis of symmetry. That is, major axis is along the x-axis if the coefficient of x square has the larger denominator, and it is along the y-axis if the coefficient of y square has a larger denominator. Previously I told you the denominator of the coefficient of x square has a larger denominator, then the major axis is along x-axis. If the coefficient of y square has a larger denominator, then the major axis is along the y-axis. Please remember these points, my children, which are very helpful in finding the equation of an ellipse. Okay, my children, right. In the case of parabola, we have discussed length of latus rectum. Suppose y square is equal to 4a is the equation of a parabola. Then what is the length of the latus rectum? Yes, 4a. 4a is the length of the latus rectum of the given parabola. Do you remember this point, my children? Right. Here also we discuss length of latus rectum of an ellipse. Okay, my children, latus rectum. Do you remember that, my children? What is meant by latus rectum? Yes, it is a line segment passing through the focus. In the case of parabola, do you remember that point, my children? Latus rectum. It is a line segment passing through the focus of the parabola and perpendicular to the axis of the parabola. Yes, sir, my children. Right. Now let us discuss latus rectum of an ellipse. Okay, my children. Right. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. Okay, my children, this is the definition of latus rectum of an ellipse. Latus rectum of an ellipse is a line segment. It is perpendicular to major axis and it passes through any of the foci, and the endpoints of the line segment lie on the ellipse. To understand this definition well, let us take this figure 11.28. Observe this figure, my children. Here this line segment AB, is passing through this focus F2. This is also CD. This is also a line segment passing through the focus F1, and it is perpendicular to the major axis. And these two endpoints lie on the ellipse CD. These two endpoints are also lie on the ellipse. So here line segment AB and here line segment CD are said to be latus rectum of this ellipse. Understood this point, my children? What is meant by latus rectum of an ellipse? Right. Now in this slide, let us discuss the length of the latus rectum of the ellipse x square by a square plus y square by b square is equal to 1. As we have found the length of the latus rectum of a parabola, y square is equal to 4ax. Do you remember that formula, my children? Length of the latus rectum of the parabola, y square is equal to 4ax. Yes, 4a. 4a is the length of the latus rectum of the parabola, y square is equal to 4ax. Similarly, let us find the length of the latus rectum of the ellipse x square by a square plus y square by b square is equal to 1. Okay, my children? Right. Please observe this figure, my children, 11.28. Observe this figure 11.28. In this figure, previously we have discussed this line segment AB and this line segment CD are said to be latus rectum of this ellipse. Yes, my children? Right. Let the length of AF2 be L. Okay, my children? Observe this AF2. This is called length of the semi-latus rectum because AF2 is equal to F2B. This total line segment AB is latus rectum, but AF2 is said to be length of the semi-latus rectum. Okay, my children? Right. Then the coordinates of A is equal to C comma L. That is equal to AE comma L. Yes or no, my children? What is the x coordinate of A? Yes, from O to F2 we have to reach O to F2 and after that F2 to A. So the x coordinate of A is C and y coordinate of A is L. But in the previous slide we have discussed the relationship between C, A and E, eccentricity of an ellipse. C is equal to AE. Do you remember that formula, my children? So we have written C value as AE. The distance of the focus from the center of the ellipse is AE. So, my children, understood this point? Understood this step? Right. Since A lies on the ellipse x square by a square plus y square by b square is equal to 1, we have, so here this point A lies on the ellipse. So let us substitute this x coordinate and y coordinate in this equation. Okay, my children? Right. Then we have A by AE whole square by a square plus L square by b square is equal to 1. Understood this step, my children? In the place of x we have substituted AE and in the place of y we have substituted L because this point lies on the ellipse. So this point should satisfy the equation of the ellipse. That is why we substituted. Understood this step, my children? Right. This implies L square is equal to B square into 1 minus E square. By solving this equation, we get here L square is equal to B square into 1 minus E square. Okay, my children. Right. By simplifying this equation, we get this value. Okay, my children. Right. But E square is equal to C square by A square. Yes, my children. So we wrote this formula. E square is equal to C square by A square. Again, C means C square is equal to A square minus B square. In the previous slides, we have discussed C value C square is equal to A square minus B square by A square. Do you remember this formula, my children? C square is equal to A square minus B square. Yes. So C square minus B square by A square. That is equal to, by splitting this fraction into two fractions, we get 1 minus B square by A square. Understood this step, my children? Right. This implies 1 minus B square by 1 minus E square is equal to B square by A square. Here E square is equal to, we got to 1 minus E square by B square by A square. This implies 1 minus E square is equal to B square by A square. So we got the value of 1 minus E square in terms of A and B. So we substitute this value 1 minus E square in this step. Okay, my children, understood this point? Right. Therefore, L square is equal to B square into, what is the value of 1 minus E square we have found here, B square by A square. So we substituted this value in this step, B square by A square. Understood this step, my children? Right. This implies L square is equal to, what will you get here? B square into B square, B power 4 by A square. Understood this step, my children? Right. This implies L is equal to B square by A. From this equation, we get, by taking the square root on both sides, we get L is equal to B square by A. Understood this step, my children? Right. Since the ellipse is symmetric with respect to y-axis, of course, it is symmetric with respect to both the coordinate axes. Yes, AF2 is equal to F2B, and so the length of the lattice rectum is 2B square by A. Previously, I told you AF2 is equal to F2B. So we have found the length AF2. L is equal to B square by A. Then the length of this line segment AB is equal to 2 into AF2. Yes, or no, children? So 2 into B square by A. Please remember this point as a formula. Length of the lattice rectum of the ellipse x square by A square plus y square by B square is equal to 1 is 2B square by A. Okay, my children, understood this point? Right.